All right, let's figure out how much work is done in compressing a shock absorber 4 centimeters from its equilibrium position. Well, we know that springs satisfy Hooke's law, which say force is equal to a constant times the displacement. The first issue we notice is that we are not given force, we are given mass, but we do know that force is computed from mass by multiplying by gravity. So force is going to be 700 kilograms multiplied by gravity, and that is going to give us 6,860 kilogram meters per second squared, which are also newtons. So that's what the force will be. And if we use Hooke's law, we are going to set this 6,860 equal to kx. And the displacement is 2 centimeters, which is 2/100ths of a meter. Now, keep in mind that when force is negative, the spring is being compressed. So you could say the force is negative and the spring is being compressed, so it's 2 centimeters left of equilibrium, but then those minuses will both cancel anyway. So it doesn't really matter whether you think of the displacement as positive or negative. If you think of the displacement as negative, you just need to use the force as negative as well. So this allows us to find the spring constant, K, equal to, let's see, we'll multiply both sides by 50. And that is going to give us a spring constant of 343,000. And that will tell us then that our force function for this particular spring is 343,000 times x. Now the question wants us to find the work done in compressing it 4 centimeters. So we'll start at equilibrium, and if we want to compress 4, we would put a -4 here. Again, it's not really going to matter whether we think of it as compressing 4 centimeters or stretching 4 centimeters, because in the process of integration, this stage right here, when we integrate, notice that we are getting x squared divided by 2. So whether we plug in 4 or -4 doesn't matter because of that square. So we will end up with, let's see, dividing by 2 there gives 171,500. And we plug in the 4 or -4, we get 16 minus 0. So we will multiply by 16, and that is going to give us 2,744,000 Newton meters or joules, whichever unit you prefer. They are equivalent.